Hello, welcome to Tennessee's at-home learning series for math. Today's lesson is for all our 8th graders out there, though all children are welcome to tune in. This lesson is the 5th in our series. My name is Candace Thompson, and I'm an 8th grade math teacher at Oakland Middle School in the Rutherford County School System. I'm so excited to be your teacher for this lesson. Welcome to my virtual classroom. Today, we will be continuing our learning about equations. In our lesson today, you will need the following: paper and a writing utensil or another note-taking device. No calculator is required today, but you could have one available to check on your arithmetic as you solve the equations. If you didn't see our previous lessons, you can find them on the Tennessee Department of Education website at www.tn.gov/education. You can still tune in to today's lessons if you haven't seen any of our other ones, but it might be more fun if you first go back and watch our other lessons, since we'll be talking about things we learned previously. Okay, let's begin. Today we are going to start working on applying our knowledge of geometry, writing and solving linear equations. You might want to draw diagrams to help represent the situations presented in the problems today. Here are some key things to remember from geometry. Supplementary angles have a sum of 180 degrees. Complementary angles have a sum of 90 degrees. Alternate interior angles and vertical angles are congruent to one another. Same side interior angles have a sum of 180 degrees. A right triangle has one angle that measures 90 degrees, and an isosceles triangle has two angles that are congruent. We also must remember the triangle sum theorem that states all angles in a triangle must add up to 180 degrees. Let's solve the following problem together. One angle is 5 degrees less than 3 times the measure of another angle. Together, the angle measures have a sum of 143 degrees. What is the measure of each angle? Don't forget to draw diagrams to help represent the situation. So we know that both of these angles here must add up to 143 degrees. And I know that a 143 degree angle creates an obtuse angle. So I'm going to draw an obtuse angle first. Now I'm going to divide that obtuse angle into two separate angles, knowing that one angle must be significantly larger than the other. Now that we have our diagram, let's explore some questions. What do we need to do first to solve this problem? First, we need to define our variable or our symbol. If x is the measure of the first angle, how do you represent the measure of the second angle? So if x is the measure of the first angle, how are we going to represent the measure of the second angle? Well, we're told that that angle is 5 degrees less than 3 times the measure of another angle. So the second angle would be represented as follows. 5 degrees less than, so we are subtracting 5 from 3 times the measure of the other angle. What is the equation that represents this situation? Well, I know the sum of these two angles must equal 143 degrees. So my equation is x plus 3x minus 5 equals 143 degrees. Now let's solve for x and determine the measure of each angle. There are some pathways to solve this linear equation, but this is just one way. I'm first going to collect like terms to simplify my equation. I'm going to use the property of equality that states if a is equal to b, then a plus c is equal to b plus c if c is positive 5. So I will add 5 to both sides, and I have 4x equals 148 degrees. From here, I'm going to use the property of equality that states if A is equal to B, then A divided by C is equal to B divided by C if C is equal to 4. So I am dividing each side of the equal side by 4. And this tells me that x equals 37 degrees. Now remember, in this type of situation, we're applying what we know about linear equations to solve this problem. And the problem asks, what are the measure of the two angles? So I'm going to use this value of x to figure out that answer. My first angle was pretty simple. It was just equal to x. Well, if x is equal to 37, then I know that my first angle is equal to 37 degrees. My second angle is equal to 3x minus 5. So I'm going to substitute in 37 for this measure of the second angle. And when I do that, I'm left with 111 minus 5. And then I know that 111 minus 5 is equal to 106. So the measure of the second angle is equal to 106. I can check my work and make sure that my work is correct by adding 106 to 37, and when I do, I get 143. Let's look at a second example. Given a right triangle, find the degree measure of the angles if one angle is 10 degrees more than 4 times the degree measure of the other angle, and the third angle is a right angle. Again, we're going to start by drawing a diagram of the right triangle. Now that we have our diagram, let's explore some questions. What do we need to do first to solve this problem? First, we need to define our variable or our symbol. Let x be the measure of the first angle. If x is the measure of the first angle, how do you represent the measure of the second angle? Well, our problem tells us that our second angle is 10 degrees more than 4 times the degree measure of the other angle. So we'll let our second angle be represented by the expression 4x plus 10. What is the equation that represents this situation? Well, since we have a right triangle, we already know that one angle is 90 degrees, which means that the sum of the other two angles is 90 degrees, because I know that all three of these angles must equal 180. So if this side is 90, if this angle is 90, then these two angles together must also equal 90 to get a total of 180. So what we can do is set these two angles together. When added, we can set that equal to 90. So my equation would look something like this. 4x plus 10 plus x equals 90. Now we will simplify our expression by collecting like terms. We will use the property of equality that states that if A is equal to B, then A minus C is equal to B minus C if C is equal to negative 10. Now I'll use the property of equality that states if A is equal to B, then A divided by C is equal to B divided by C if C is equal to 5. And x is equal to 16. Now, remember that there are other pathways to solve this linear equation, but this is just one way. Now that I have what the value of x is, I have to plug that back in to find the angle measures of each angle. So my first angle was represented by x. Well, I know that x is equal to 16, so my first angle is equal to 16 degrees. My second angle was equal to 4x plus 10. So I'm going to plug that in. I'm going to plug in I'm going to plug in 16 for x. And when I simplify that expression, I get 64 plus 10, which tells me that the measure of the second angle is equal to 74 degrees. And then, of course, I know my third angle is a right angle, and that all right angles are 90 degrees. Is there another way that I can check my work just to ensure that all angle measures are correct? Yes, I could add up all three angles and make sure that the sum of them is 180, like the triangle sum theorem states. All right, let's try some other examples. Here is your first problem. You try these. Don't forget to define the variable first and to draw a diagram to help you visualize the situation. I'll give you some time to work, but remember, you can also pause the video and come back and compare our answers. It says a pair of congruent angles are described as follows. The degree measure of one angle is 3 more than twice a number, and the other angle's measure is 54 5/10 less than 3 times the number. Determine the measure of the angles in degrees. Let's check your work and see how you did. First, we have to note that a pair of congruent angles. That tells me that both of these angles must be set equal to one another because they have the same measure, same angle measure. And they're described as follows. The first angle is 3 more than twice a number. Well, let's define our variable. If we let x represent a number, then 3 more than twice a number, this expression 2x plus 3 would represent our first angle. And I know that these angles, again, are congruent to one another. So I'm going to set this equal to my second angle measure. And that says the other angle's degree measure is 54 5/10 less than. So I'm going to be subtracting 54 5/10, if I didn't say that correctly, then 3 times a number. 3 times a number. Because the angles are congruent, again, their measures are congruent. We're setting these expressions equal to one another. Now let's solve and see what you came up with. I'm going to start by using the law of equality that states if A is equal to B, then A plus C is equal to B plus C, if C is 54 5/10. So I have my new equation. Remember, thinking back to our previous lesson, the goal is always to have your variable set equal to a constant. If I get rid of 3x, it's not mathematically incorrect if you subtract 3x right here, but remember, it doesn't get you any closer to achieving your goal. So we want to subtract 2x. And so we have 57.5 is equal to x. Now, again, I'm trying to figure out what each angle measure is. If I figure out one, then I have figured out the other because, of course, they are congruent. So let's plug in this value of x to see what we come up with. I'm going to start with this left side. I'm going to plug in 57 5/10 for x plus 3, and I end up with 118. If I do that on the left side, I should also come up with 118 because these angles are congruent. And I do. How did you do? Let's try another example together. Here is guided practice number 2. Remember, if at any point you need to pause the video so you can work, you can do that and then check your answers compared with mine. Practice number 2 says as follows. A triangle has angles described as follows. The measure of the first angle is 4 more than 7 times a number. The measure of the second angle is 4 less than the first. And the measure of the third angle is twice as large as the first. What is the measure of each angle in degrees? Be sure to draw yourself a visual for reference. We are talking about a triangle. And we're talking about 3 different angles in this triangle. So be sure to plug in those expressions here. I'll give you some time to work. And again, you can also pause the video. Are you ready to check? Let's see how you did. So here is my triangle, and it says that the measure of the first angle is 4 more than 7 times a number. So my first angle is going to be 4 more plus 4, 7 times a number. I'm going to let x represent a number. I'm going to define my variable. So my first angle measure is 7x plus 4. And my first angle I have here, I'll write it a little bit bigger, 7x plus 4. Now the measure of the second angle is 4 less than the first. So I'm taking this expression for the second angle and I'm subtracting 4. Well, notice if I subtract 4, I'm just left with 7x. So for simplicity, I'm going to leave this as 7x. Finally, it says the third angle is twice as large as the first angle. So I'm going to take this expression that represents the first angle and I'm going to multiply it by 2. Now what I would suggest you do is if any of your expressions can be simplified, such as the expression that represents our third angle, let's go ahead and do that. Our first angle is already simplified. There's no distributing that needs to take place, no combining of like terms. So I'm going to write out that expression, and this represents our first angle. Our second angle, again, no simplification needed. Our third angle, I can simplify that. I'm going to distribute, and when I do, I have 14x plus 8. And I know because of the angle sum theorem that when I add all of these expressions together that are representing each of the angles, that it should equal to 180 degrees. From here, I'm going to simplify by collecting like terms. I'm going to do 7x plus 7x plus 14x to get a grand total of 28x. And I'm going to do positive 4 plus 8, which would give me 12. And I'm going to set that equal to 180. At this point, I'm going to subtract 12. And I have 28x is equal to 168. At this point, I'm going to divide by 28, and I get that x is equal to 6. Now, don't forget that this is not where your answer stops. I have to use this value of 6 to figure out the measure of all angles. So, I'm going to start with my first angle. The first angle was represented by, let's write it over here. The first angle was represented by 7x plus 4. I know that x is equal to 6. 7 times 6 is 42. Plus 4 is 46. So that tells me that the measure of the first angle is 46 degrees. The second angle was represented by 7x. So I'm going to plug in 6 for x. 7 times 6 is 42. So the measure of the second angle is equal to 42 degrees. And then finally, I have the third angle. Now, I simplified that expression. So originally it was 2 times 7x plus 4. I'm going to distribute that, and I ended up getting 14x plus 4. Now I'm going to plug in 6 for x. And when I add that together, I get 92 as the measure of the third angle. Now, how can I double check to make sure that all three of these angles are correct and that I haven't made a mistake? Well, I know that all three angles should add up to 180. So I can use that to check my work. Now, let's recap on some of the highlights of our lesson. We know that an algebraic method for solving equations is more efficient than just guessing and checking. We know how to write and solve equations that relate to angles, triangles, and geometry in general. We know that a drawing of a diagram can sometimes make it easier to understand a problem, and that there is more than one way to solve an equation. Now try these two problems as your exit ticket today. I'll give you some time to work, and you can, of course, pause the video. The first one states, given a right triangle, find the measures of all angles in degrees. If one angle is a right angle and the measure of the second angle is 6 less than 7 times the measure of the third angle. Take some time and work this one out on your own. Okay, let's check your work and see how you did compared to my answers. So I have a right triangle. That tells me that I'm going to have one angle that equals 90 degrees. So I'm going to put that the first angle is equal to 90 degrees. The second angle is, the measure of the second angle is 6 less than, so I know that I'm subtracting 6. 6 less than 7 times the measure of the third angle. I'm going to let x be my variable here, so this will represent 7x, and then the third angle is going to be represented by x, because this one is 7 times the measure of the third angle. If I let x represent the third angle, then I have to make sure I note that here. Now I'm going to write my equation. I know that all three of these angles should add up to 180 degrees. So 90 plus 7x minus 6 plus x equals 180. I'm going to collect like terms. So I have 8x plus 84 equals 180. I have 8x equals 96, and I have that x equals 12. Now remember, I'm not finished. I have to plug this in. So I'm going to go back here, and I'm going to plug in 12, and the measure of the second angle will be 78 degrees. And then of course, since the measure of the third angle was just represented by x, I'm going to get what I solved for x, which was 12, to be the measure of the third angle. Now let's look at the second problem on your exit ticket. It says, in a triangle, the measure of the first angle is 6 times a number. The measure of the second angle is 9 less than the first angle. The measure of the third angle is 3 times more than the measure of the first angle. Determine the measure in each angle of degrees. Take some time and work this one out on your own. Are you ready to check your answers? Let's see how you did. For the first angle, you should have got the expression 6x. The second angle, you should have got the expression 6x minus 9. And the third angle, you should have got the expression 3x plus 6x. Whenever you created your equation, you should have added all of these and set it equal to 180 degrees. When you do that and you solve for x and then use that value to plug it back in, here's what you should have got for each angle degree. The first one was 54 degrees. The second angle measure was 45 degrees. And then the third angle measure was 81 degrees. I enjoyed doing some mathematics with you today. Thank you so much for inviting me into your home. I look forward to seeing you in our next lesson in Tennessee's At Home Learning Series. Goodbye.